You scroll past 100 photos today without thinking twice, but your eyes stop just for a fraction of a second on a particular shape. You don't choose this. Your brain does it before you're even aware you're looking. And the reason has nothing to do with fashion or movies or Instagram. It reaches back nearly 2 million years to a woman standing on a savanna, deciding whether to keep walking on two legs. This is a story about bipedalism. It's a story about fat storage, hormones, and spines. And somewhere in the middle of it, it's a story about why one part of the human body became one of the most visually charged shapes on Earth. Let's start with the walk. Around 6 million years ago, our ancestors left the trees. Chimpanzees and gorillas still knuckle walk, spreading their weight across 4 limbs like a table. But once early hominins stood upright, everything changed. The spine now stacked vertically over a single point of contact with the ground. Something had to hold that structure up. Something had to stop the body from pitching forward with every step. That something is the gluteus maximus, the largest muscle in the human body. And it didn't get that way by accident. Dr. Daniel Lieberman, an evolutionary biologist at Harvard, has spent decades studying human locomotion. His research shows this muscle barely fires when we walk slowly on flat ground, but start running or climbing a hill, and it switches on almost instantly. Lieberman's work suggests it evolved specifically for endurance running, the kind our ancestors needed to chase prey across open plains for hours, long before spears and arrows made hunting easier. So the first answer is mechanical. It's an engine, a stabilizer, a brake. But machines don't need to be beautiful. So why did this stabilizing muscle also become a visual signal? Here's where fat comes in. Women, on average, carry significantly more fat in the hip and thigh region than men do. This is called gluteofemoral fat, and it behaves differently than the fat stored around the belly. Belly fat is linked to inflammation and disease. Gluteofemoral fat is a slow-release energy reserve. Researcher Devendra Singh, working out of the University of Texas, proposed that this fat exists to fuel two of the most expensive processes a human body can undergo: pregnancy and breastfeeding. A developing fetus needs a steady supply of specific fatty acids, especially the kind used to build a baby's brain. Singh's research suggested gluteofemoral fat is uniquely rich in these compounds and gets mobilized right when an infant's brain is growing fastest. This isn't random padding. It's a nutrient reserve, built for a future child's nervous system, years before that child exists. And if a visual signal reliably predicted access to that reserve, it would have carried real information over evolutionary time for anyone choosing a mate. Not consciously, but bodies that signaled fertility and metabolic reserve would have had an advantage generation after generation, until the signal itself became something brains were wired to notice. This is the logic behind the waist-hip ratio hypothesis. Singh's cross-cultural studies found a consistent preference for a particular ratio between waist and hip circumference, hovering near 0.7 in many populations. Consistent enough, Singh argued, that fashion trends alone couldn't explain it. Notice something. None of this has required a cultural explanation yet. Just skeletons, muscles, fat cells, and reproduction. But culture does complicate the picture. Anthropologist Ann Becker documented something striking in Fiji during the 1990s. Before television arrived, larger bodies were widely linked to health and status. Within a few years of Western television reaching the islands, Becker found sharp shifts in how young women described their own bodies, along with rising rates of dieting that hadn't existed before. The underlying wiring, the parts shaped by walking upright and storing fat, sets the stage. But which exact shape counts as ideal in a given decade gets negotiated by media, economics, and culture. So you end up with two systems running at once. One ancient and slow, built by millions of years of upright walking. The other, modern and fast, rewritten every few years by magazines, algorithms, and celebrities. There's one more piece worth knowing, because it explains why this trait provokes such an immediate response. Human vision is unusually fast at detecting curvature and ratio, faster than conscious thought can intervene. That isn't unique to this trait. Vision evolved to snap judge shapes that mattered for survival: ripe versus unripe fruit, healthy versus sick animals, stable versus unstable ground. Researchers studying attraction argue the waist-hip signal taps that same fast, pre-conscious system, because for most of human history, that split-second judgment about a mate's fertility carried real reproductive stakes. Paleolithic Venus figurines, carved tens of thousands of years ago across Europe, consistently emphasize wide hips and rounded proportions, often leaving the face blank or unshaped. Whoever carved those figures, long before agriculture or writing existed, chose to emphasize exactly the traits tied to fertility and fat reserves. That pattern wasn't invented by a modern advertising industry. It was carved in stone first. Anthropologist Helen Fisher, known for her research into the biology of attraction, has argued that signals like this evolved because they're difficult to fake. A skeleton shaped by years of hormone-driven development can't be counterfeited the way a costume or a posture can. Nature tends to trust the signals that are hardest to fake. So when your eyes catch on a shape today, what's actually happening is layered and old. A skeleton reorganized for upright walking. A muscle built for endurance running. A fat depot storing nutrients for a child's developing brain. A visual system trained over millions of years to read that signal in a fraction of a second. And on top of all of it, a modern culture constantly redefining what counts as ideal, sometimes in ways that have nothing to do with the biology underneath. None of this is really about vanity. It's about a body plan that let a bipedal ape outrun its prey, feed its offspring's brain, and survive long enough to pass all of that machinery down to you. Tonight, you'll scroll past 100 photos without thinking twice. But somewhere in that scroll, your ancient eyes will catch on a shape your ancestors were reading, for entirely different reasons, 2 million years before there was ever a screen to scroll.